Again, let's continue looking at rational expressions. This time we're going to combine them using arithmetic operations. So for example, here we have a subtraction and an addition of a bunch of rational expressions. Here we have a multiplication, and here we have a division. So we're going to combine them and then simplify them. So let's start with this first one. We have x plus 2 over x minus 2 as our first rational expression, minus x minus 6 over x plus 4, there's our second, plus 4 over x squared plus 2x minus 8. Okay, now to simplify these, we have basically, you want to think of these as fractions with different denominators. So this has x minus 2, this has x plus 4, and this has something else, right? X squared plus 2x minus 8. Now when we have, when we're trying to combine fractions with addition and subtraction, we have to have the same denominator before we can add them. So we want the same denominators here. For polynomials, it's usually, I would say, a little bit easier than dealing with, I guess, really large, like natural number denominators. Those you'd have to factor down and try to figure out, which is the least common denominator. With polynomials, x minus 2, that's going to be a factor. That doesn't factor any further. X plus 4, also a factor, doesn't factor any further. X squared plus 2x minus 8, oh, well, that might factor. So let's factor this and see if there's any factors of this that are common to these two. All right, so we've got x squared plus 2x minus 8. Let's just go ahead and rewrite this. So we've got x plus 2 over x minus 2 minus x minus 6 over x plus 4 plus 4 over, and now we'll factor this. So this is a quadratic. See, there's no common factors. So we'll look at the first term here has a 1. That's great. So that means we look at the constant. It's negative 8. We need pairs of factors of negative 8 that add up to 2. Right? And you're probably thinking plus 4 minus 2. That's right. So we've got x plus 4, x minus 2. All right. Now, very nicely, these two factors are the same as these two factors. Right? So to make a common denominator, we won't have to do anything to this term. With this rational expression, we need to introduce a factor of x minus 2. And with this one, we need to introduce a factor of x plus 4. Right? And we do that by multiplying by 1. Right? To get an x minus 2 in the denominator, we'll have to multiply by x minus 2. I'm going to put those in parentheses. But we cannot just multiply the denominator by something. That would change this expression. We also need to multiply the numerator by that as well. So net right here, we're multiplying by 1. That gives us this rational expression with the two factors of the denominator that we need. Right? So these match. Right? We'll do the same here. We're going to multiply by x plus 4 over x plus 4. Also 1. Okay. Now all of the terms here have the same denominator, and we can now add them. All right. Before we do, let's just go ahead and multiply out these binomials. So we have x times x is x squared. X times 2 is 2x. 4 times x is 4x. So 2x and 4x is 6x. And then 4 times 2 is 8. Okay, here we have minus. And since we have a minus sign, I want to put this in parentheses. So that will remind me to change the sign later. X times x is x squared. Minus 2x, minus 6x, minus 8x. And then we have plus 12. And then plus 4. All right, now all of this is over. our factor denominator, x plus 4, x minus 2. And I didn't multiply out the denominator because I'd like to simplify the numerator first and then look for common factors. So there's no reason to multiply this out just to factor it again when we try to simplify. Okay. Now we'll distribute this minus sign. So I'm just going to go ahead and change the sign of that x squared. We've got to change the sign here and change the sign on this 12. All right, that takes care of that minus sign. And now let's see what simplifies here in the numerator. We've got an x squared. We've got a minus x squared. That's 0. We've got 6x, and we have 8x, that's 14x. And then plus 8 minus 12 is negative 4, plus 4 is 0. So we have 14x over x plus 4, x minus 2. All right. Now you can see there are no common factors between the numerator and denominator, and so we're done. We can go ahead and list our restriction on x. X cannot be negative 4. X cannot be 2. All right. So to add and subtract rational expressions, we need common denominators. Right? Once you have that, we want to multiply things out and simplify, if possible. Don't forget to include the domain restriction. All right, let's look at multiplication and division. These we will not have to have common denominators, so I guess in some sense it might be simpler. Let's take a look at this first one. We have a product here of x squared minus 9 over x plus 1 times 2x plus 2, divided by x squared minus x minus 6. All right, when we multiply, as you know, to multiply fractions, multiply the numerator, multiply the denominator. It's no different here. We'll have x plus 2 minus 9, x squared minus 9 times 2x plus 2 times x plus 1 times x squared minus x minus 6. All right. So we could multiply out and distribute, but since everything is a factor already, we've got this thing times this thing, we should just factor everything and then see if there's any common factors. So x squared minus 9, that's a quadratic, and that factors. Do you see how? X squared minus 9 is the difference of two squares. So we can go ahead and factor that as x plus 3 times x minus 3. Over here we have 2x plus 2, and you might notice that both of these have a common factor of 2, so we can factor that out. I'll just put that right here. You could also write it out front. X plus 1. 2 times x is 2x, 2 times 1 is 2. Okay, so we've taken care of all the terms in the numerator. Let's put that over the denominator. We have x plus 1. Already see a common factor. And then this, x squared minus x minus 6. That's a quadratic. So factor that. Go ahead and pause the video and find the factorization of that. All right, x and x, it's like minus 3 and plus 2. Okay, so here we have a factored numerator and a factored denominator. Let's write down the values of x that must be restricted or excluded, then we'll cancel. So we have x minus x cannot be negative 1, x cannot be 3, and x cannot be negative 2. All right, now let's cancel common factors. We saw an x plus 1. It's out. X minus 3. x plus 3, 2, and x plus 2. Nothing else. All right, so we have 2 times x plus 3, just going to write the 2 first, over x plus 2. Right. And we'll include the restriction on x. We'll start with the smallest to the largest, just to make it look pretty. Here we go. Okay. So multiplication, just mash everything together as a product, factor it down, and simplify. Again, don't forget the domain restriction. Okay, division, very similar. To divide fractions, we know that means to multiply by the reciprocal. So we want to immediately take this division of 2 rational expressions and write it as a product. So it will be this one, this x squared minus 3x minus 4 divided by x minus 2 times the reciprocal of x squared minus 2x minus 8 over x minus 2. So let's write that immediately. So we've got x squared minus 3x minus 4 over x minus 2. I'm going to multiply by x minus 2 over x squared minus 2x minus 8. Now, we have to, when we have this division, we still have to exclude the denominator of the part over here, the thing that is the rational expression that is being divided, or that is going into the other rational expression. So we'll go ahead and exclude that 2 right now. It happens to be over here as well, but we'll take care of that. All right. And now we'd like to cancel any common factors. We're going to treat this just like a multiplication. So it looks like we have some common factors already. We can go ahead and factor the numerator. So we've got an x and a, let's see, a minus 4 and an x plus 1. And we also have an x minus 4 and an x plus 2. All right, I'm going to go ahead and cancel these out. So x minus 4 times x plus 1, that's the factorization of this quadratic. X minus 4 times x plus 2 is the factorization of this quadratic. All right. Now we will note all the values that must be excluded. We have 4, so we'll add that to the list, and negative 2. All right, and now we can cancel. So we've canceled the x minus 2, good. We can cancel this x minus 4 that's common. These two do not have any common factors, so we have x plus 1 over x plus 2, where x cannot be negative 2, 2, or 4. All right, so in this video we've looked at adding and subtracting rational expressions, multiplying and dividing. Now these skills, being able to add, subtract, multiply, and divide rational expressions, and also to simplify and note the values of x that must be excluded, are critical to solving rational equations, which we will look at in the next video. I'll see you there.